All right, welcome to a very important lesson here in chemistry, the mole. So a mole in chemistry is an amount of units. Um, what that means is it's similar to other amount of units, such as 1 dozen. When we say 1 dozen, we're referring to 12. I'm sure you guys are all familiar with that one. One you're maybe less familiar with is a score. Whenever you hear the word score used as a representation of numbers, it represents 20. So Abraham Lincoln in his 4-score address, he was talking about 80, 4-score. There's a gross, which is 144, and there's a ream, which is 500. So these are all common units of amount. In chemistry, we use what we call the mole, which is a big, gigantic amount, 6.02 times 10 to the 23rd. So it's a very large amount, but it does the job we need to do it. So the mass of one carbon atom, so the need for the mole here, the mass of one carbon atom is approximately 12.011 atomic mass units, which we usually abbreviate AMU. So if we're taking a look at this in grams, that would be 1.99 times 10 to the negative 23rd. So that's a lot of spaces behind the decimal here in standard notation. Most balances that we use in lab only go to the 100th spot, so that's right there. Even our most precise balance that we have an analytical balance, it only goes to the 10,000th spot, that's right there. That is still a long, long way, millions and millions of times away from how close it would need to be to measure the mass of an atom. So we're a long way off. What we need is something that can convert for us from AMU, from the mass of one atom, to grams, something we can measure more easily. So 1 AMU times what equals 1 gram? And that blank, that something just happens to be the value of the mole. So that 1 AMU times 6.02 times 10 to the 23rd is equal to 1 gram. So there's the value of our mole. It allows us to go from AMU to grams pretty simply. So anytime you have a mass in AMUs, it's a pretty straightforward conversion to grams per mole. Now notice it's not just grams, it's grams per mole. So one atom of carbon has a mass of 12.011 AMU, or 1 mole of carbon has a mass of 12.011 grams. Again, that's grams per mole. It's an important distinction there. But again, that mole allows us to just look at the periodic table. Yes, that's a mass in AMU, but we can very simply, very quickly convert it to a mass in grams per mole because of that value of the mole. And that's the value of the mole. I always found this substance, or this chart, a really, really helpful chart. So hopefully you guys do as well. There's basically 3 conversions we're going to be making, and moles happens to always be in the middle here. So you might have grams of a substance, and you want to know the number of moles, in which case you divide by the molar mass. That's the molar mass is the mass we just looked at, the grams per mole on the periodic table. If you wanted to go from moles of a substance to number of atoms or molecules, you would take whatever moles you have and multiply it by 6.02 times 10 to the 23rd. Going the other way, let's say you have a number of atoms or molecules and you want to know how many moles you have. You would divide that number of atoms or molecules by 6.02 times 10 to the 23rd. And once more, going the other way, if you have a number of moles and you want to get to a number of grams, you would multiply it by the molar mass. And the molar mass is the listed value on the periodic table. Just kind of a quick side note here. The value of the mole, that 6.02 times 10 to the 23rd, is named in honor of an Italian scientist, Amedeo Avogadro. And Avogadro did a lot of work with molecules, especially gas molecules. We'll learn more about him when we get to our gas unit later in the year. All right, so taking a look at some examples for molar conversions. So for example, you might be given a problem. What is the mass? When we're working with mass, we'll usually be working with grams. What is the mass of 3.5 moles of copper? All right, well, we're back to a factor label type of problem. So again, I'm going to list my question mark, grams of copper is equal to what they gave me, 3.5 moles of copper. Now I've added a 0 there, and I really shouldn't. That looks like a typo. The question only gave us 2 significant digits. That 0 would be significant because of the decimal, so shouldn't probably be there. So 3.5 divided by 1 times, here's our mass off the periodic table. Again, it's 63.546 grams of copper off the periodic table over 1 mole. That's grams per mole. So we do our 3.5 times 63.546, and we get 222.411. Again, looking back, I've added a significant digit. It should probably just be 220 grams of copper. Looking back at our question here, there's only 2 significant digits, 3.5. I'm not sure where that 0 came from. Let's take a look at the next one here. How many moles of aluminum are contained in 11.9 grams of aluminum? Again, I'm setting that up. Question mark moles of aluminum. That's what I'm looking for. Is equal to 11.9 grams of aluminum. Okay, this time I know I need grams on the bottom because I need to get it to cancel out. So that value off the periodic table is 26.981539 grams of aluminum per mole of aluminum. We do the division there and we get 0.44105. We only wanted 3 significant digits, so that 0.5 are insignificant, and we should just have 0.441 moles of aluminum. All right, this time we're involving atoms. Atoms of silver. How many moles are present in 1.20 times 10 to the 8th atoms of silver? Well, the overall problem doesn't change at all. I'm going to start with a question mark. What am I looking for? In this case, I'm looking for moles of silver. We have, the question gave us, 1.20 times 10 to the 8th atoms of silver. Now, instead of using the molar mass, I don't have a mass, I need to cancel out atoms. This time, I need to use the Avogadro's number. There are 6.02 times 10 to the 23rd atoms of silver in 1 mole of silver. And there we go. We have crossed off atoms of silver. We only have moles of silver left. We do our math. We adjust for significant digits. 3 significant digits. 3 significant digits. 1.99 times 10 to the negative 16th moles of silver. And finally, we'll use a problem here where we use all 3 steps. How many grams of copper are present in 3.01 times 10 to the 23rd atoms of copper? Okay, so again, like I said, we have to use all 3 steps. We're starting with atoms. We need to get to grams. We'll have to go to moles first. Moles is that middle step there. So question mark grams copper, it's what we're looking for, is equal to, hopefully we're in the habit now of then writing down what the question gave us, 3.01 times 10 to the 23rd atoms of copper. First step, I need atoms to cancel out. I need to put atoms on the bottom. There are 6.02 times 10 to the 23rd atoms of copper in 1 mole of copper. Again, I know that atoms of copper goes on the bottom because I need it to cancel out. Next step then, I'm left with moles of copper. So now I know that moles has to go on the bottom. I'm looking for grams. I find that value off the periodic table, 63.546 grams of copper in 1 mole of copper. Now all my units have canceled out, except the one that I'm looking for, grams of copper. I can do my math, 3.01 big E 23 divided by 6.02 big E 23 times 63.546. I got 31.773. We only have 3 significant digits, 3 significant digits. This one has 5 significant digits, but we're going to be limited to 3, so we'll round that 7 up to an 8, and we're going to call it 31.8 grams of copper.